This section is on different types of angle pairs, and we'll start off with adjacent angles. These are the characteristics of adjacent angles. The basic idea is that they're angles that are next to each other. But to be more precise, this would be an example here, angle 1 and angle 2. To be more precise, though, they share the same vertex, and you see these do. They have to share one side. Here's the side they share here in the middle. And they must have no overlapping interior space. So just to try to clarify the idea, here's some counterexamples. These two share a side here. They don't overlap, but they don't have the same vertex. Vertex for the angle on the right's up here, angle on the left it's down here. These two share a vertex, no overlapping area, but they don't share a side. And these two, they share the red side, and they have the same vertex, but they overlap. This 2/ angle goes over the 1/ angle. So these are all non-examples. This is an example of adjacent angles. Basically, for the adjacent angles, if you take the measure of the two and add them together, you get the entire angle. So that's the angle addition postulate we've seen before. Now a linear pair. A linear pair are these two adjacent angles that form a straight line, and so therefore they're supplementary. So linear pairs always add to 180 because they're two angles which are adjacent, so they're next to each other, and they make a whole line. A whole line's 180 degrees. So linear pairs are always going to be supplementary. However, just because two angles are supplementary, it doesn't mean they're a linear pair. For instance, this random angle here, 80 degrees, this one over here, 100. It's not really to scale. It should be a little bit more, well, obtuse, so maybe more like that. They may add to 180, so they may be supplementary, but clearly they're not a linear pair because they don't form a line as shown there. So linear pairs are always supplementary. The supplementary are only sometimes linear pairs. And supplementary means add to 180. Now here's vertical angles. Vertical angles are the angles formed by the intersection of two segments or lines or rays, and they're the opposite ones. So angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. So the opposite angles and vertical angles are congruent. Now let's take a look at the sample problem. Now these three angles here, well, these two are adjacent, these two are adjacent. All three together form a straight line. You wouldn't say they're all three supplementary because supplementary just means two angles, maybe 180. So they're not all linear pair. However, the three of them, you could say, I suppose, a linear triplet. Now what that means is that if you add them all up, their measures, you get what a straight line would be, which is 180, and now it becomes an algebra problem. So we combine like terms, subtract 20, divide by 20, and now we'll plug 8 back in to get the measures of all these different angles, 26, 106, and 48. And finally, before we do some more practice, just to make sure we got it, supplementary, two angles that add to 180 degrees, complementary, two angles that add to 90 degrees. Okay, this practice sheet is all about using these properties we've just talked about to set up algebraic problems and then solve them. That's the idea. So in this case, these are vertical angles, therefore they're congruent. So you set them equal to each other, subtract 2x from both sides, add 40 to both sides, so x is 30. Over here, these two are a linear pair, therefore they're supplementary, therefore they add to 180. So you don't set them equal to each other, you add them and set them equal to 180. This cancels, I get 12y is 180. Divide both sides by 12, and y is equal to 15. All right, these three angles together are 180. Because this is 90 over here, we know that these two will be the other 90. So 4z minus 10 plus z, that has to be 90 because 90 and 90 is 180. And then we've got 5z, and I'll add 10 to both sides, is equal to 100. So z is 20. Same idea for this one. Because this is a right angle, we know that the remaining number of degrees is 90 along this straight line. So 9x plus 4 plus 32 is equal to 90. So 9x, I subtract 36 from both sides, is equal to 54. Divide by 9, and x is 6. Okay. A couple different ways to do this one. We know that these two are congruent because they're vertical. These two are supplementary because they're a linear pair. It's probably easier to deal with the vertical ones. So I'll say 4x plus 1 is equal to 65. Though alternatively, we could have said 4x plus 1 plus 7x plus 3 equals 180. Subtract 1 from both sides, and then divide by 4, so x is 16. And then finally over here, if this is 90, we know that's 90 because they would be vertical. So therefore, 4y plus 6y is equal to 90. 10y is equal to 90, and y is equal to 9. Okay, down here, We have this picture, true or false. Angle 1 and angle 2 are vertical. They're not vertical because they're not on opposite sides of this intersection, so that's going to be false. They'd actually be a linear pair. 2 and 3 are supplementary. That's true. They're a linear pair. The linear pairs are supplementary. 1's equal to 3. The measure 1's equal to measure 3. That's true because they're vertical. 3 plus 4 is 180. That's true. A linear pair is supplementary. 1 and 3 is 180. Theoretically, it could be true if they're both 90, but it doesn't have to be true because they have to be congruent since they're vertical, but not necessarily supplementary. And angle 4 and 2 are adjacent. That's also false. They're not next to each other. They are a vertical pair. Okay, some conclusions. Well, let's see. You could say that this is 125 in here. You could say that these two are each 55. That's the idea with the conclusions. This is congruent to this one. You could say that this is congruent to this one because you know that they're both supplementary to these, and since these are congruent, these are congruent. So that's the kind of idea there.